Swayam Prabha. Digital India. Educated India.
Okay, so welcome back. So we will continue our discussion on plastic waste management issue, which is the kind of the topic for this particular week, where we are looking at different plastic waste management options, different technologies, different methods. So if you remember in the previous 3 videos for this week that we have already you have gone through, we looked at the recycling aspect, the mechanical recycling, and also recycling of the source material. And then we also looked at waste to energy aspect. We looked at the plasma gasification, pyrolysis. So all those different ways in which this plastic waste can be managed. So if you cannot do any sorts of treatment, say if you cannot have cannot do plasma pyrolysis, you cannot do waste to plasma gasification, you cannot do incineration waste to energy, or cannot be recycled for some reason, then one of the option left is which is the least favored option, is to go for landfilling. So landfilling, we don't want to do landfilling, but say if there is no other option left, so if rather than letting the garbage scattered around, letting the plastic being littered, we put it in a secured environment. And landfilling is not the dump sites that we see in India. It's the landfilling is essentially an engineered structure where you put some control in terms of the leachate treatment, leachate collection and treatment, as well as the gas collection. So that's so essentially it kind of you are trying to put your unrecyclables, non-recyclables, non-treatable plastic waste into the landfill, and to put it in a secure environment so that the adverse impact from these plastic waste is minimized. So that's the whole goal here. So landfilling is a very old technique. It has been used for many years, and it's used for municipal solid waste. It is also used for hazardous waste as well. We have hazardous waste landfill. So plastic waste essentially will come as part of the municipal solid waste. So whenever we have this plastic waste, it's essentially it's a part of municipal solid waste, and it's so if you cannot do any treatment or any you cannot treat the plastic, you cannot do waste to energy, then you take the waste to nearest landfill. And where that if you in the landfill, what happens is there are since it's a mixture of waste, you will have some wet organic waste, you will have some dry waste. So wet organic portion, they do decompose, but this waste plastic, since they are non biodegradable, they remain consuming the space and thereby reducing the life of landfill. So that's why landfilling of plastic waste is kind of very least preferred option. We don't want to put plastic waste in a landfill, but if there is no other option, at least it helps in securing like we can put it in, we can reduce the adverse impact from coming out from this plastic waste, because they create problem in terms of aesthetics, they create problem in terms of the visual disturbance, and it can also in a landfill scenario, once this plastic gets broken down into microplastic, it can go through the leachate collection system, and then it can also go to the groundwater table, contaminating the water, because the leachate treatment systems are not designed to remove these microplastics. So as we talked about microplastics earlier, they are very tiny plastics, and then they may just get through the leachate collection system. So that's that becomes a problem. So that's why again landfilling is an option, but not a preferred option. So this is a typical landfill how it looks like, and so this you have a liner system at the bottom. So you have this is your liner system, where you have like a you have a compacted clay or compacted clay in association with the geomembrane. So, you have these liner system at the bottom. On top of liner we have the leachate collection pipes which will collect those leachate, and so then you have this plastic liner, then you also have a clay, and all around it we do monitoring wells where you look at how much if there is any contamination, and leachate will be collected and taken out for the leachate collection. And you also have the gas collection system which is not shown here. So, you will have a several gas collection pipes, gas collection wells is drilled in here which will collect the gas, and then there will be a main header pipe which will take this gas out and can be used for energy and other sources. So, as you can see from the sketch, landfill, municipal solid waste landfill, which we talk a great detail in our waste management course, which again will be offered like a rerun in July. So, but it is essentially like a huge polythene bag. So, it is a HDPE is your polythene there, it is your high density polyethylene. So, you can think about this like a huge, as you can see this liner all around. So, this is like a huge polythene bag which you have, and you are putting garbage in there, and you are trying to control the adverse impact coming out from those garbage. So, that is in terms of how the landfill works. Again, landfilling for plastic is the least option. The number one is we try to recycle the plastic. If we cannot recycle, because if it is mixed, we cannot put it in a recycling system. Next we try to do is waste to energy, resource recovery, and all those. We do not really want to put plastics in the landfill, but sometimes when you do not have any other option, you have to kind of go for putting plastic in a landfill environment, which sometimes it is inevitable and you go for that. So, in terms of pros and cons, we kind of talked about that. It is the cheapest and easiest management option, requires less technical expertise because you just put the garbage in there, you are not really doing much. So, less technical expertise, cheapest. So, that is why many times it gets used. You are putting carbon in there, and so you can capture, you can control the carbon getting out from there. So, it is kind of part of the carbon sequestration. You can think about that, which is essentially carbon sequestration means that you are not letting carbon go to the atmosphere. So, that is the whole point of carbon sequestration. It is aesthetically and environmentally it is an acceptable solution if it is properly managed and monitored. So, again, landfill is used only when we do not have any other option left. So, that is the place where we use landfill, especially for plastic waste. Engineered landfills are a better option than uncontrolled dumping and burning of plastic waste. So, that at least you are controlling the environmental impact. So, that is the good part of landfilling, like if you do not have treatment options, you can landfill this plastic. Disadvantage, it is a low density material, they contain lot of space, lot of energy for transportation, compaction, low biodegradability. Essentially, there is hardly any biodegradability of plastic. Plastics do not biodegrade much easier. Bioplastics are there which will biodegrade, but most of traditional plastics, they are designed to be non biodegradable. So, they interfere with the closed utilization of closed landfills in terms of creating a recreation space. They also sometimes hamper the growth of plants in the area. The protective liner used in the landfill separate waste from the soil and groundwater resource may leak or rupture in future, we do not know. In that case, we can have this microplastics getting into the groundwater, and it can lead to some soil and groundwater contamination in future. And it is a loss of land, because once you go for a landfill, you are essentially losing that land and material as a resource. So, it is a last disposal option. So, when you do not have any other options out there, then it is a last disposal option because it at least helps in controlling the environmental impact. So, that is the good part of landfilling. So, if you look at the management options, so this is we try to put together this chart to give you a kind of a big picture of what we have discussed in this week so far. So, kind of a summary. So, we will try to go through this and a kind of recap. This will be like a recap for you what you have done in last what you have heard and read about in last 3.5 videos. So, here mechanical recycling, which we talked about, and feedstock recycling, waste to energy, landfill, and these two recycling, that is we were looking at. So, when we say mechanical recycling, what we are doing essentially sorting, float separation, micro sorting, solvent separation. Using some solvent, we are trying to separate different chemicals out there. For landfilling, dump sites, sanitary landfill, those are the place. Here for feedstock, pyrolysis, co-pyrolysis, gasification, waste to oil, waste to energy. So, that is what we are talking about. Waste to energy, incineration and co-incineration, those are kind of waste to energy. So, here if you look at, we have tried to have two color coding here. One is the light green and that is the light blue. So, the light green one is the environmental factors, light blue is the economic factors. So, for each one of these categories, we try to put these two factors there. So, if you look at the mechanical recycling, it reduces greenhouse gas, saves energy, conservation of material. So, it is from an environmental point of view the benefits. Cost effective, reduced resource exploitation, create jobs, that is the from an economic point of view. Similarly, for feedstock recycling, degrades plastic, few air emissions, high capital cost, liquid oil, syngas and char, which can be used as a resource. Waste to energy, electricity produced, you can do the revenue generation. Environmental issues, air emissions, bottom ash and fly ash management. So, we have to kind of focus on that. For landfilling, land acquisition is always an issue, energy and material loss. And in the positive side, it is kind of carbon sequestration, it prevents groundwater pollution. So, that is kind of what a landfill. So, that is a kind of a big picture. If you like, I just try to understand in a summary. Of course, we went into detail for many of those aspects, but if you think of in a summary for plastic waste management. So, these are the methods, these are the most common ways of managing plastic today for a good portion of plastic. There are some other applications which we will talk about after this. So, there are some other applications of plastic, some innovative way people are coming up to putting those plastics in different products or different kind of applications, and we will see some of those in this week as well. So, but this is kind of, I thought I will just put a summary there, so that you can have a good idea of what we talked about, and it would kind of recap for you from the previous material. There is also a concept of circular plastic waste management. Now, circular economy, circular plastic waste, we will talk more in detail about circular economy and circular plastic waste management in the last week, which is the week 8. But since we are talking about plastic waste management, we thought I will just give you a very quick kind of summary of what really we mean in terms of circular economy when we talked about plastic waste management. So, in terms of plastic waste, as you know, you will have once plastic leaves home, once done with plastic it leaves home. Plastic material that are not recycled should be placed in curbside garbage for pickup. So, you put it over there in the curbside garbage, you have this plastic material. Then non-recycled material are picked up and transported to an energy recovery facility. It goes to waste to energy plant where the energy is generated, and you get the energy. In some waste to energy plants, non-recyclable material are used as a fuel to generate electricity. In other conversion plants, non-recycled material are used to generate fuels, that is diesel or etc. or chemical. So, either it could be fuel or it could be directly using it the heat and from the calorific value and going for an energy. So, and then it goes to the grid, and from the grid you get the energy to the house. So, this is turning non-recyclable plastic into energy. So, that is that is one way of where you try to do the waste to energy, and emissions are subject to strict controls, and that is for energy. But if you try to go for recycling, again you have the plastic, it goes into the material collected, plastics are taken to a material recycling facility, gets converted into grounded, clean, grounded, processed and recycled pellets. From pellets, making of new product, and material that are not recycled can be sent to energy recovery facility. So, and that's one way where we are getting the plastic in, and we are trying to just use it in different fashion under like a group of industries, and that is how we are trying to get energy out of that. We are trying to recover resource out of that, and that's kind of the concept of where you are trying to bring the plastic back into the plastic waste back into the economy. That is the whole concept of circular economy, and which we will talk more detail in the last week. But this is a concept, just an example of how circular economy concept can be used for plastic waste management. So, there are some other examples of plastic usage. We will go over that little quicker. These houses are made with blocks made from waste plastic. So, this was done Concepts Plasticos in Colombia. So, they took plastic and then made blocks, and those blocks have kind of a layer of cement and other stuff on top to prevent to give a fireproofing, and then they are used in houses, and they are pretty strong. They do meet like sometimes the brick standard. So, because we ourselves I had a master's student couple of years back, like around a year back, and he took plastic and we compressed it, made a small bricks of those plastic, and then we tested traditional bricks with this like plastic bricks, and we saw that it does able to attain at least the level of strength that it for the single storied building, for a boundary wall, for even like a security post and all that. It can be used. It can be used in those applications. Recycled plastic is used in paving stones. These paving stones are solid and cheaper and than typical paving slabs. So, it's available. It's being used. Then let's here you see an example of where the recycled plastic was used in building home. So, this is a BBC small report. So, I want you to watch this report, and again I will keep quiet. You can listen to that report, and that's how you will see that how the plastic is used in this particular structure, which you see right in this particular slide. So, let's look at this small video, and then we will talk about that.
కానీ 3 నెలల కాంచి ఉంటున్నా. ఇక్కడ బెడ్రూమ్, కిచెన్ అనే అన్నీ మంచిగా ఉన్నాయి. అది ప్లాస్టిక్ నుంచి తయారు చేశారు, వేస్ట్ ప్లాస్టిక్తో తయారు చేశారు మొత్తం.
అతను వాళ్ళు ఏం చేస్తారు తెలుసా? తెలీదా?
Recycling of plastic obviously is a wonderful business opportunity. First thing, as you know, plastic cannot be stopped. So either we have to reuse or it will go to landfill. So, as you saw that this was this house is not a
simple like a brick and mortar house. It's all made from plastics, plastic bags, which was and plastic was sorted out, as you saw by the rack pickers. They were sorting it out, and then it gets compressed and made into these plastic bricks. One of the, if you watched it carefully, you also saw that although it meets the standard, it meets the strength requirement, but many times people are not ready to take it because the consumers are always worried about new stuff. So they are also worried about what is the kind of what could potentially be the negative aspect of this plastic home. And then but the other place where the gentleman who is the entrepreneur here is trying to make more like sales or more business is with the plastic tiles. So that's where the tiles, as mentioned, it is less than $1. So it's, you can look at maybe around 65 rupees per tile. So that's the price. So it has, again, anything whenever you go for newer material, newer stuff, there has to be competitive. So one thing this video was also talking about, that if you go for a plastic house where you make a plastic house, it comes out to be costlier than regular house. So and then people have a skepticism for plastic house at the first place, and then if it comes out to be costlier than regular house, then obviously people will say that why should I go for a regular house? Why should why should like I not go for a regular house? Why should I go for a plastic house? It's cost me more, and I have a lot of uncertainty associated with that. So that's why these things struggle sometimes. But again, things do move slowly, and it will get done. So these are some of the initiative which is happening in different places of the world, including in India. So then co-processing of plastic waste in cement kilns, again that's happening for quite some years. It's you put it in alternative fuel and raw material in terms of in cement kiln. It simulates what it does is substitutes primary fuel and raw material by waste. One of the advantage of recovery method of used in existing facilities, eliminating the need to invest on other plastic waste practices and secure landfilling. So you can use that as a fuel. So that's as long as we can separate it out. So different feed points are there. It can be the main burner of the rotary kiln, it could be rotary kiln inlet, it could be pre-calciner, it could be mid kiln for a long and dry wet kilns. So they are there are different places where this plastic waste can be fed and used as an energy source in these in co-processing of plastic waste in the cement kiln. So if you look at a flow diagram, how things are done for plastic waste in cement. If you start from beginning, you have the raw material, limestone, clay, silica and iron ore. So you have a stock yard for raw material, then you weigh it, then you have a dryer mill for waste for the raw material. You have preheater, burning, clean burner, clinker, and then finally grinding. So that's how the whole process works. So you have alternative raw material in solid, then you have alternative raw material in powder. You have you have cinders and fly ash. Then you have wastewater, waste liquid added. We have alternative fuels in the heater. Could be waste plastic, and chips, wooden chips, weather paper, kaolin clay, fine slag, carbon, and all that. So that's you can have some preheating, then burning, which is then around 1450 degrees centigrade. Then you have clinker, and then you have after clinker you have this grinding, and you get the material in terms of gypsum or other things that is being formed. So this is a flow diagram for co-processing of the plastic waste in cement, and that's how it is done. So use of plastic waste in roads are also is quite popular nowadays. Use of plastic in roads. The road construction uses waste plastic, popularly known as the plastic roads. They are found to perform better compared to those constructed with conventional bitumen. So plastic roads mainly uses carry bags, disposable cups, and PET bottles that are collected from garbage dumps as an important ingredient for the construction material. So if you look at this, other than the plastic carry bag, the disposable cups and to some extent disposable the PET bottles or easily recyclable. So, there is a right competition of PET bottle going to the recyclables or going to the roads. So, that is we need to kind of make a decision on that as a country. So, that is it's an important ingredient of the construction material, because the plastic roads, when mixed with hot bitumen, plastic melt to form an oily coat over the aggregate, and the mixture is laid on the road surface like a normal or tar road. So, that is what it looks like. So, why use plastic in road construction? It is durable, corrosion resistance, it is a good binder, economical, makes sense to do it, it is longer life, maintenance fee, ease of protection, processing, installation, lightweight, improves aggregate impact value, increases melting point of bitumen. So, those things why it helps in terms of bitumen construction, like road construction. So, plastic waste used in road construction, there are films, carry bags up to 60 micron thickness, 60 micron thickness. You have polyethylene, polypropylene, polystyrene, hard foams of any thickness, soft foams of any thickness, laminated plastic cups up to 60 micron. So, these are the one which can be used in road construction. What cannot be used is PVS sheets and flux sheets. So, those two cannot be used in road construction. So, once you have the basic process here is you segregate it, you clean it, you shred it, and then you collect it. After collecting, you go through the dry process and the wet process. Dry process is aggregate is heated to 170 degree centigrade in mini halt plant. Shredded plastic waste is added in equal proportion. In the wet process, waste plastic is directly mixed with hot bitumen at 160 degree centigrade. Since the wet process requires a lot of investment and hardware plants, so we are focusing on dry part only. So, then there is addition of stabilizers, proper coating, system mechanical stabilizer is needed and all that. So, it is the dry process which is more popular and which you will see mostly used. So, in terms of dry process, plastic, when we go for the road construction, you have aggregates, hot aggregate, plastic coated aggregate, plastic coated aggregate, bitumen mixture. So, and the road laying is typically done at the typical range of 120, 140, 150 degrees centigrade. So, overall this is how plastic waste is used in road. So, we will talk more about that in the coming video. So, so we have been focusing on plastic waste management, different aspects. So, we looked at traditional ways of different ways of managing plastic waste. Now, in this last video, which will be after this, we will have the last video, and there the focus will be that how it is being used outside landfill, outside recycling stream. What are the things that are being done to make plastic waste management more competitive, like getting the informal and formal sectors kind of a good interaction in terms of making this plastic waste management a great success. So, with those kind of discussion, let us stop here, and we will continue this discussion of plastic waste in roads and some other issues in the last video, which will be the last video for next video, which will be the last video for this particular week, which is week 6. So, thank you, enjoy watching, and I hope if you have any questions, please do not hesitate to put on the discussion forum. Thank you.